Ever wondered how AI tackles problems that even humans find mind-bending? Think about optimizing delivery routes for thousands of packages, or balancing a power grid in real time. These aren't simple math puzzles. They're dynamic, ever-shifting challenges where perfect answers are practically impossible to find. Today, we're diving into LLaMA, a groundbreaking tool designed to test how well AI systems can solve these real-world conundrums. Let's unravel the science behind it. So what exactly is LLaMA? Imagine a virtual coding competition where AI doesn't just write code once and call it a day. Instead, it's more like a marathon. AI systems test their solutions, refine their code based on feedback, and keep improving over days or weeks. This mirrors real-world problem-solving, where solutions evolve as new data or constraints emerge. Here's the catch: these problems are computationally hard. Scientists classify them as NP-hard, a category of problems where finding the absolute best solution is practically impossible, even for the smartest algorithms. Take a delivery route puzzle with hundreds of stops. The perfect path exists, but calculating it would take longer than the universe has been around. That's where LLaMA shines. It's not about getting a single correct answer. It's about teaching AI to iteratively improve solutions, just like a human competitor would. What sets LLaMA apart? Unlike traditional benchmarks that prioritize speed and exactness, this tool mimics real-world workflows. AI agents can test their code, visualize results, and refine their approach, like having a real-time debugger. It even includes leaderboards and performance graphs to track progress over time. Think of it as a training ground where AI learns to adapt, not just memorize. Researchers tested cutting-edge models like GPT and LLaMA on LLaMA. The results? Some models aced specific tasks, but here's the twist. Humans still outperformed AI in two critical areas. First, consistency. AI struggled to apply the same strategy across different problems. Second, long-term thinking. Humans refined solutions for weeks, while AI often plateaued. It's like comparing a sprinter to a marathon runner. AI can run fast, but it's still learning how to keep going. So what's next? LLaMA isn't just a test. It's a stepping stone for AI to tackle real-world challenges. From optimizing supply chains to managing energy grids, this research shows how AI is evolving. But it also highlights what's still ahead, teaching machines to think like humans with patience, creativity, and persistence. Thanks for watching. If you want more deep dives into AI, science, and tech, hit that subscribe button. And drop a comment below. What real-world problem do you think AI should tackle next? Let's keep the conversation going. Let's break down how LLaMA actually works. Imagine you're watching a movie of your code's journey. The tool offers two visualization modes, a local preview for quick checks and a web-based animator that shows how code runs step by step. It's like seeing a recipe come to life. Every line of code gets its moment in the spotlight. Once the AI thinks it's ready, it submits its solution to a private evaluation. Think of it like a secret exam, hidden test cases, same as the original competition. But how do they measure success? There's the scorer's score, a report card for code. Some problems compare scores to others, while others just add them up. Then there's overall performance, which stacks AI against human competitors. And finally, the rating system, a leaderboard for machines. But fairness is key. LLaMA restricts languages to C++, Rust, and Python. No peeking at forbidden websites, no code copying. It's like a coding competition with a referee, no shortcuts, just skill. Here's a cool hack: parallel testing. Instead of running one test at a time, the system blasts through multiple cases at once, saving hours. And if you're really into it, you can replicate the whole setup on cloud platforms like Oz. It's like having a supercomputer in your pocket. LLaMA isn't just a tool, it's a playground. By simulating real contests, it helps AI learn, compete, and push boundaries. It's a lab where machines challenge each other in ways humans never could. Next time we'll dive into how AI agents actually solve these problems, so stay tuned. If you enjoyed this deep dive, hit that like button and subscribe for more adventures in AI. Until next time, keep coding, keep learning, and remember, even the smartest AI starts with a single line of code. Let's unpack the data. When researchers tested models across different score ranges, a pattern emerged. For example, 24% of models scored between 400 and 500, with an average of 5.67. But as scores climbed to 1, 600, 1, 700, the percentage dropped to just 0.2%. It's like climbing a mountain. The higher you go, the fewer reach the peak. The mean SD numbers, like 5.67 plus or minus 1.03, show averages and variability. A high standard deviation means some models crush it while others lag. Take the 1,500, 1,600 range. The average is 16.27, but the spread is 8.48 points wide. It's like a classroom where one student aced the test and another barely passed. GPT-4 mini scores 1,293 in short tasks, but drops to 1,114 in longer challenges. Gemini 2.5 Pro stays steady at 1,389 versus 1,301. It's like comparing a sprinter to a long-distance runner. Each shines in their own race. And costs? They vary wildly too. One model might cost 1 cent per problem, while another eats up 13 cents. This isn't just about raw performance. Higher scores often mean higher costs or more complex systems. Take open hands. GPT-4 mini jumps from 687 to 991 in longer tasks. It's not about being better overall, it's about matching the right tool to the job. So next time you see AI benchmarks, remember, these numbers aren't just stats. They're a story about innovation, limitations, and the endless quest to build smarter systems. Thanks for watching.